project what's on the second screen in the recording. If you look at the assignment schedule, I was getting ahead of myself. I was thinking, oh man, we're on chapter 2. And then I realized, oh, wait a minute. No, we're taking it easy. We're going to make sure we get a good handle on section 1.3 and 1.4 this week. And then look what's coming up. We got an exam on the 14th. So let's make sure we get a good handle on slopes and the point slope form. And take a look here then at these assignments. And I don't have a worksheet here, although we do have these worksheets. I can look at these. I forget how far we got last time, but let's get a really good handle on slope. Maybe, well, for the start here, I'm going to do something here on the board, going over the whole idea of point slope. And let's look at the text, because it gave a little help here. I'm going to open that in a new tab. In the text, oh yes, I'll take it to that link. In that online text, they talk about the slope form, the rise over run. We have the slope M, and then they talk about the point slope format coming later, where we're going to given a point and a slope, we can figure out what the point slope format should be. Well, let's start right here. The slope of a line between 2 points. X1 and Y1, X2, Y2. Let's go ahead and draw this out in my notes here. I'm going to stop projecting that and let you see my camera here. And now on the board here, we have this line, or this graph. We're going to draw a line here. We're just going to draw a random line like so. And we'll pick 2 points on it. We'll call this X1, Y1. X1 comma Y1. And this is, let's see, pick another point on our line. X2 comma Y2. 2 points on our line. To calculate the slope, you will actually get the same number no matter which order you do it. Normally, I think to myself, the Y change, I think of this Y and that Y. We're going down, so I'm expecting a negative slope. But I can calculate the slope this way. I can say slope M equals, let's see, the difference in Y, Y2 minus Y1, that's the difference in Y. That's the change in Y, also known as the rise. I like to call it a change in Y, or delta Y. The change in the X, here's the important thing. If I started with Y2 up there, I have to start with X2 down here. I have to do it in the same order to get my correct slope. If I happen to have the points in the wrong order, did you know that I can do the same thing? I can say also, if I just happen to have the points in the wrong order, I can also do Y1 minus Y2 over X1 minus X2. I will get the same slope. But what's important is if I start with Y1 here, I have to have X1 here on the bottom. So it doesn't matter whether or not one point is over here. You don't have to start with this point, or you don't have to start with this point. The important thing is you do the same order. Y2 minus Y1. If you're going to do 2 there, you have to do the X2 minus X1 on the bottom. If you do the other way around, Y1 minus Y2 at the top, make sure it's X1 minus X2 at the bottom. And one way of seeing that is y2 minus y1 is just the opposite of y1 minus y2. Well, if I do the opposite of that, and I don't do the opposite of the one on the bottom, then my slope is going the wrong direction. But if I do the opposite of that one on the top, and the same opposite of that one on the bottom, I will end up actually getting the same number. Anytime I have 2 points, I can get a slope. Even if I'm given a table of 10 different points, if I want the slope of that line and I want to figure out the equation, all I need is 2 of those points in a table. What's useful though, if I have a table of points, to graph them, it just makes sure that they all do actually follow along the line. If I'm giving a bunch of points and they're not lined up, depending on what 2 points I choose, I'll get a different slope. Now from this, the thing we want to get from this is, okay, a point slope format for an equation for a line. Well, sometimes there's multiple ways of displaying a linear equation. The hardest part is actually finding the real-world problem that you can put into an equation form. Once you have the equation, the math part all falls together. And to me, the challenge has always been, okay, what is a problem that I can, how do I get that word problem into the actual equation? That's the challenge. The thing is, at this point in our algebra, we don't have to worry about that part. We leave that up to the people giving us the numbers, that they have figured out some equation. In the start of the chapter, they mentioned, you've got this skateboard company and they're producing skateboards. They figured out some equations, and they're just saying that if we have equations about profit and the materials cost, we have an equation. As long as we know our algebra, we can solve that equation. And let me bring up, let's see if I can find that part of the book here. We're back here. Let me bring that screen down for you. So we're at this part of the equation. Let me present that here to you online. There's that equation we have. We have that slope. Given any 2 points on the line, we can come up with our slope. And I like the form of a linear function. I like to see it this way. This is an easy way to visualize it. Y equals m times x plus b, where m is the slope, b is the y-intercept, where it crosses the y-axis. I like that because it looks like a function. I get y when I have a certain value of x. M and b are constants that I have figured out from my equation. But sometimes you'll come across something that doesn't look like that. You'll have something that looks like this. ax plus by equals c. That's just a different form of another linear relationship. And I'll let you see my camera here online. That's just another form of a linear relationship. Here is y in terms of x. Here is a combination of, if I have a times x plus b times y, I'll get c. That is another linear equation, just in a different format. There's another format called the point slope format, that if I have a point, I'll call it P, is a some point x1, y1, and I have a slope well, I have a slope m. The point slope format is, well, we'll derive it. I know that m equals, well, anytime I have a point x, when I subtract, or sorry, anytime I have a point xy, y minus y1 over x minus x1 will give me my slope. And I know I go through the point x1, y1. Well, another way to write that is multiplying by x on both sides. I can say m times x minus x1 equals y minus y1. Given point, some point x1, y1. So if I'm told, here's the slope 3, and it goes through point 1, 2, the point slope format would be 3 times x minus 1 equals y minus 2. There is your point slope format given the point 1, 2, and knowing that the slope is 3. So they will ask you sometimes in your assignment, give me the point slope format, given a point and a slope. This is what they're asking for. And we'll find an example of that here in the book. And did someone come in while I was? Who was that? Cameron? Okay. And did Rashida? Yeah, Rashida came in too. I'll get you marked up. Now, any questions about that? Let's think through. I want to make sure that's clear enough. And with algebra, you just have to kind of keep going over and over. It's like, okay, now I got that. And we're going to go over it some more now. Any questions about this particular one? Drawing the picture, laying it out. We always know that this is a slope. And what we're saying here with this problem is, I have point y1 and y1, x1 given to me, like here. That's y1, x1. The general format is, I know if I had some other y, x and y, that my slope would be that. So now that I know that, I know what my slope is, x minus 1, if that's the point, y minus 2, if that's the point I go through. This is my formula for my line in point slope format. I can always change this and put it into slope y-intercept format. Let's do that just for fun. So I'm going to take that formula. This is point slope format. Point slope. Let's take that and put it into the format mx plus b format. M times x plus b format. Well, here's what we do. Well, I know the slope is 3, so I know m is going to be 3. So I know it's going to look like something like 3x plus something. Well, let's see how that would work. Let's just, all we have to do is get the y by itself. Well, look at this. I've got 3x minus 3 equals y minus 2, because I multiplied out the 3's. Well, to get the y by itself, I just add 2 to both sides, and I get 3x minus 1 equals y. And just to make it look nice and uniform, I just reverse those. Y equals 3x minus 1. So I've gone from point slope format to mx plus b format. Well, let's go into this just general linear equation format. That is a matter of, let's see here, let's subtract 3x from both sides, so negative 3x plus y equals negative 1. Or if I want to just multiply by both sides by negative 1 to make it a little easier to read, I can say 3x minus y equals 1. Now I have it in the general linear equation format. These are all the same line. Point slope format, slope y-intercept format, general linear equation format. So all we're doing here is manipulating the formula to just make it look to be in different forms. It's the same relationship, the same function. Why would I do this? Why would you put it in different formats? It depends on how you're trying to solve the problem. You may have a problem that says, if I know the slope and y-intercept, here's an easy answer, and an easy way to find the answer. Okay, then I'll put the formula in that format, and I can just then plug it into the solution, and I've figured out the answer. If I read somewhere else and say, if you know A and B and C, here's the answer to that problem. Well, if I put it in the A, B, and C format, then 3 is A, negative 1 is B, C is 1. And I crank it through some formula that takes A, B, and C and gives me some interesting fact. So if I have an AX plus BY plus equals C format, I put it into some formula machine so that solves that. If you know A, B, and C, then I can solve some amazing equation. Then I'll plug it, I'll find A, B, and C, 3, negative 1, and 1, plug it in, and I get some cool answer. If someone else says, you know, if you knew what M and B were, you could solve some cool problem. Okay, I'll put it in, figure out what M and B are. M is 3, B is negative 1, and I get some other amazing answer based on just feeding it M and B. That's why we have these different formats. As we get more complex polynomials, if we have it in a different form, we can plug it into a solution finder. Some real genius mathematicians found a way. If I know A, B, and C, I can solve the problem in this way. So different forms for different approaches to the problem. And sometimes you'll see the problem in this form, and it's a lot easier to understand when you have it in this form. So then we put it in that form because it's easier for us to understand how we got that in that format and then some other solution. So it's all the same line, just different formats of expressing that relationship between the solution or the problem that is represented by a linear equation. Ready to look at a thing at this point, we'll take a look at one of the little online quizzes here. Let's present that screen. And let's take a look. How about this little problem, 1.3. Let's take a look at these and see if these are going to be hard to understand. Let's take a look. We've seen this on the worksheet last time, kind of threw it at you. This time it's in red, maybe a little easier to see. Right away, what's the slope? Should jump out to you in that red line. What's the slope?
It does not exist.
Because it's a vertical line. Anytime a vertical line, you can express it as it's a vertical line, but in terms of mathematical slope, you can't say it has a slope. So D and E would be the answer. This one. Different ways, can I zoom in on that? There we go. Different ways of expressing how would I find the slope? And as you practice, sometimes it'll just pop out right at you. Yeah.
-5, -5.
-5, -5. Reduce it to?
-1.
So I'm going through -5 and -5, but what's my slope? Think of when I go over, how far do I go down?
-1.
Every time I go over 1, I go down 1. Over 1, down 1, meaning negative. First, when I just take a look at this, I know if I'm going down from left to right, I know it's going to be a negative number. The distance here is 5. Even though I'm at x equals -5 here, the distance from here to here as I go left to right is 5. So 5 over takes me 5 down. So 5 over plus 5 divided by, going down, -5. When I go 5 over 5. So -5 divided by 5 gives me my slope. Another quick way to look at it, when you have an easier one like this, you can see, hey, 1 over, 1 down, 1 over, 1 down, -1 every time I take a step. That's another quick way to look at this one. So, slope would be -1. Type in -1, there we go. Okay. Now this one. Quick way to look at it is where it crosses the boundaries of my graph. Here it crosses, so I could quickly go, I go over 4, go down 1. I know it's going to be negative, going left to right. So every time I go over 4, I go down 1. What's my slope? Or think of it this way, I go down 1 for every time I go 4 over, -1 over 4, right? Over 4, down 1, -1/4. 1/4. 1/4 down, 1/4 down, other 1/4 down, another 1/4 down, 4 over, 1 down, 1/4, -1/4. If I like the formulas, I could put in y2 minus y1, -3 minus -2 is 1 divided by x2 minus x1, -1 minus -5 is 4. So -1/4. Yeah, -3 minus -2 is negative, so it's -1 over 4, -1/4. So looking for where it crosses exactly the axis is the easiest way. And then see, oh, went down 1 after going over 4. Negative, I always know it's negative when it's going down left to right. So in here would be -1 divided by 4. And we have one more. Right away, I know this one is going to be positive. It's not going at 45 degrees, so I know it's going to be more than 1. Positive 1 will be hitting the grid, right? On the way up there at a 45-degree angle. Remember, it doesn't always have to go through 0. A quick way to look at this, go over 1 means I go up 3. Every time I go over 1, I go up 3, so rise is 3 for every x. That's what's nice about these. Whenever it's just one X between, it hits the grid, 1 over, I know right away, all I have to worry about is how many I went up when I went over by 1. If I go up 3, every time I go over 1, slope of positive 3. So graphing makes it a little easier, but graphing takes a long time. So we'd rather, as we get more and more equations, we start plugging in the numbers instead of having to go graph it every time, because graphing takes a lot more time. When I have that graphing calculator, I can do it really quick. Now this one right away, you don't even have to think about this one. When you see a horizontal line, you always know the slope is 0. So the whole point of the graphing is just to visualize what they mean by the different slopes, get a feel for it. 45 degrees up, that's a 1. 45 degrees down is a -1. And as they get steeper, the number should get larger. But just watch for how many I go over every time I go over, what's the rise, what's the change in Y when I go over 1. And let's see if we got the answer right. This is all there is to this one? Woo! Now, we'll take you to the next one. Is that the only question in this? Oh, there we go. I keep forgetting how I get to the next one. Now we're given a different one. This one, again, the formula line is already given to us in the mx plus b format. So, how easy could it be? I know that that's my slope. Think about it this way. As my y will change, whatever's multiplying x here, I get 0x, I get 7. I get 1x, that means, well, I've gone down 4. Every time I have another x, I go down 4 more. So I know my slope is -4. So whatever's multiplying by the x is my slope. So recognizing the mx plus b format. And as you get into more complicated math, it becomes recognizing the pattern, recognizing the form that the equation is in, and going to your tool set of solving problems based on what form the problem is in. I have different ways of solving my problem. Here it's just a matter of recognizing that my slope is -4. And the y-intercept. When x is 0, that's the y-intercept. So just throw in a 0 where x is, and I get -4 times 0 plus 7. So I know 7 is my y-intercept. And once I'm happy recognizing the mx plus b, I know right away, without even thinking, 7 is my y-intercept. I recognize the mx plus b format. And I submit the question, and do I have a space in there or something that's messing it up?
No, you have to do like the 0, 7.
Oh, it's a point. They're not asking for the value. They're asking me for a point, yeah. So I wonder, yeah, parentheses around 0, 7. When I think y-intercept, I just think, oh, it's x is obviously 0.
I did the same thing on the homework.
Okay, yeah. All right. So recognizing the form it's in, they gave you an easy problem. Now, if they gave you a different format and then ask you for the slope, it takes a little bit more work. Let's see if they're doing that for us. Now, there we go. We got to get the slope and intercept. All we do with this one now is to convert it to the other form. And I'll do that one on the board just to make it clear. If anyone is watching the recording, do exactly this kind of work. Has anybody found a good program that lets you do the work on screen? Drawing? I'm thinking of getting I have a stylus pad. I'm horrible at drawing with my mouse. But I'm trying to look for a good way I can show you the solution as I draw it on the screen. Other than the stylus pad, I don't know a good way. So I'm going to switch to the camera. And it's 5x minus 8y plus 1 equals 0. Okay?
You could use like Microsoft Paint maybe on the.
I was thinking of that. I started Paint here, but I'm so bad with the mouse that it was looking horrible. But that's the thing I'm thinking about. 5x minus 8y plus 1 equals 0. We need to put that in the form, the mx plus b format. Or y equals mx plus b. So we want to get the y by itself. And then it'll automatically be mx plus b. So to get the y by itself, well, I see y is negative here, so I don't like negatives if I can avoid them. So let's add 8y to both sides. So 5x plus 1, I've got to make sure I'm not in the way of your camera there, equals 8y. See how I added 8y to both sides? Now, divide by 8, so I have y by itself. 5 over 8x plus 1/8 equals y. There is my m, and there is my b, my y-intercept. So 0, 1/8 would be my y-intercept, and the slope would be 5/8. Let's see if it's happy with that solution. 5/8. Yep, and y-intercept, got to put it in the point format, 0, 1/8. Didn't like something about that. Try that again. 0, 1/8. Now it doesn't like it. It thinks I'm using a comma wrong. What did I do wrong? Try the parentheses. 0. Let's see if I don't put the 1/8 there. 0, 1. I know the answer is wrong, but see if it doesn't complain about the comma. Still saying invalid use of comma. Maybe let me just try 1/8. Now why it's not letting me go? Now the editor's gone crazy. Doesn't want me edit it now. Let me leave it and come back. No? Okay, it doesn't want the point this time. Okay, thank you very much. Sometimes it wants the point, other times it doesn't. That time, it liked it as a point. This time, it only wants, and it's not letting me go. That's weird. Last time, what did I do last time? If I hover over, let's try it back. See if I can go back to the.
I think we'll get 3 tries per line problem.
Oh. Okay. So that one, even though maybe it's the dash, the y without the dash, it wants just the number. We'll see if we can figure this baby out. Maybe it just happened to be that point. Okay, now we got 2 points. And since we have room, let's go ahead and do those 2 points. We have the points 8, -5, and 9, 1. And remember, you got to do it in the right order. Doesn't matter what order. You don't have to even worry about what order. Just start with the first one. 8, -5, -5, and 9, 1 are the 2 points. All right. y2 minus y1. Let's just go the slope equals y2 is 1 minus -5 divided by, and be sure to go the same order, 9 minus 8. And 1 minus -5 gives us,
Isn't it -8?
oh, it is a -8, sorry. 9 minus a -8, I wasn't watching. 9 minus -8 gives us a different number. 9 minus -8 gives us 17. And that's not reducible. They haven't asked for the intercept. I'd have to figure out, if they ask me for the intercept, maybe on the next problem. Let's put in 6/17, see if they're happy. Now, yeah, 6/17 is my slope. And we're happy. Now let's see. They could be asking me for my Y-intercept at this point, because anytime I have 2 points, I know I have enough to figure out the line. Given 2 points, I can draw a line between them. I know the slope of my line, but I can also find where it crosses the x-axis. But they're not asking me for that, so I'm not going to worry about that. If I have 3 points, I have more than I need. It may throw me off if the 3 points aren't exactly lined up. Give me an inconsistent set of data. So it's always safest, linear equation, I only need 2 points. Next one. Find the slope. Boy, they're giving me easy problems. This one, again, jumping over to, I forgot if I'm letting you see this on screen here. Jumping over to the graph there, very much like the other one. I go over so many, I go up. I know it's going to be a positive number. I know if I go over 4, I go up 3. 3/4 sounds like a good slope. Now, if they asked me to do the work or something, I'd have to do all that calculation of slope, but just looking at the graph, they did all the work for me with the graph. 3 divided by 4. 3 up for every 4 over. Don't have to think on this one, right? What's my slope?
0.
Horizontal line, right away, slope of 0. 0 and vertical lines jump right out at you. Vertical lines does not exist. Horizontal lines, slope of 0. Oh, look at that. I already know the answer. Doesn't matter where it is on the graph, any vertical line has a non-existent slope. Let's see if it'll take lowercase. I think it'll take lowercase. Yep, it converts it to uppercase. And remember, the motivation behind here is we're solving some real-world problem that's a linear problem. Before going on here, how about a little input over the weekend? Did you think of any, or did you come across any ideas of linear problems, real-world linear behavior? Mine was the rubber band stretches more it stretches a given amount every time I have so much weight on it. 1 pound, it stretches 1 inch. 2 pounds stretches 2 inch. Well, then I know it has a linear relationship. Is that true for all weights on the rubber band that I had? Is it linear forever? At some point, it's going to break, right? But otherwise, it's linear when I start from 0 weight to maybe, I'm guessing that bungee cord might have held 100 pounds. So the domain would be 0 to 100 pounds, gives me a linear behavior. Does that happen with metal springs? Will that same thing work for metal springs? take a metal spring, stretch, stretch, stretch. At some point, I've straightened out my spring completely, and it's no longer linear. I would bet you the force versus distance for a metal spring, the distance, we'll call the distance D, and the force F. As the force goes up, it stretches, 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 and then at some point, I think it's going to not stretch anymore, and finally break when I get so much force. So there is a limit when I'm talking about forces on springs. Can you think of any other linear relationship? They brought one up at the beginning of the book. You make so much profit per skateboard you're selling. Well, your profit is how many skateboards have I sold? Linear, easy problem. Driving to Nashville, linear problem. How much gas do I use based on how far I go? Well, is it really linear? If I'm going uphill, it's a different number than if I'm going downhill and down into Nashville. You get a lot better mileage. So on average, you might say, well, you can estimate it to be a linear function, but it's actually low mileage, high mileage, low mileage, high mileage as I go. Little, if I just measured from between two cities, I'd get one mileage, might get another one later on. But in general, it sort of goes down like a line. The further I go, my gas is kind of coming down like this. My gas tank, the gauge though, is not linear. My gas tank, as I'm driving, goes really, really slow, really, really slow. Once I get to about a fourth of a tank, it drops off much more quickly. Because I think it's getting to the smaller end of the tank or something. Not linear, and my wife's panic is not linear. As it gets down to 1/4 tank, she starts to panic about, we better find a gas station. Because she doesn't want to run out of gas. So the panic, measuring the panic as a measure of where the gauge is not linear. Once you get to 1/4 tank, the panic number really rises exponentially. As long as you can measure something or come up with a number to attach to something, you can see, is it linear or is it not quite linear? How about this function? When I throw a baseball up in the air, how high it is it a matter of time as it falls? Is it linear as it falls? The distance that a baseball is in the air from the ground, when I throw it up, so I measure it as a function of time. Is it linear? Well, if I throw it up, it goes up, 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 up. Does it keep going up? 1 second it's 10 feet, 2 seconds it's 20 feet, 3 seconds it's 30 feet. Maybe at the start, but then it starts to slow down because of gravity. And then it starts coming back. So it's not linear unless you measure between me and my son that I'm throwing it to. Further he is away, it takes maybe twice as long to get to him. But as you measure a longer distance, you can see, oh yeah, that the path of it is curved. I have to throw it faster to get it farther. It's not quite linear as I really measure it carefully. But if I'm playing ball with my kid just 2 feet away, it looks like 3 feet away. It's just a little longer to get to them. But as you measure precisely, you'll find it's not quite a linear equation. And for me, that's the fun part, actually solving some real world problems. So right away on this one, do I know the slope? Got the same x and 2 different y's. See that right away? You see, if you want to draw it in your mind, draw the graph, or just think to yourself, oh, I have the same input, I get 2 different outputs or 2 different y's. It's a vertical line. 1 x, 2 y's. I know right away does not exist. And as you work on them, you'll recognize, oh yeah, same x, vertical line. So DNE for that baby. Ready to look at the next one? And maybe we'll do, maybe I'll make some up for you just to give you some good practice. And again, just a quick look, positive or negative. Left to right, if it's going down left to right, you know it's a negative slope. That's just the rule. Left to right, as y decreases, y, the run or the rise is negative. This y, y2 minus y1 is a negative number. So therefore, and the run is going to the right, the run is positive, I'm going left to right. So I know, regardless of knowing what y2 and y1 are, that it's going to be a negative number as I subtract this number, smaller y, I subtract a larger y from a smaller y. Or a more negative y is subtracting a less negative y. I'm going to get a negative number all the way. Now here they've given us, they're attempted to represent a real world problem, and this is where, to me, it's always the motivation why we do all these linear equations. And thinking of the more interesting nonlinear equations like the path of the baseball or the football or the arrow. Most things are not linear, but a simple formula, I get more profit selling so many bottles. And there's my formula, 85 cents per bottle. But the 322, what does that represent? That I get profit. My profit is negative until I've sold so many bottles that it's higher than 322. What do you think 322 represents? I have negative profit if at the start. If I haven't sold any bottles, I owe somebody $322. Do you think he had to pay $322 to get a case of bottles? Hasn't sold any of them yet, so he's out $322. Now as he's selling them, he's making a little bit more, finally breaks even when this is equal to 322, and then the rest is profit. So pretty realistic problem here. They don't explain this, of course, but they just say, here's the formula. I would rather they say, he sells bottles at 85 cents each. He has to buy a case of them for $322. What's the formula? That's the more likely scenario. You'll be given a problem, you have to figure out, let's put it in math format, and then we can solve or answer different questions. So interpreting the slope, what they mean there is, what does 0.85 mean? Well, to me, it jumps out that, okay, every time I have another bottle, I get another 0.85. Well, that must mean the price of each bottle is 85 cents. I'm guessing that this represents dollars. It could represent yen. He might be in a different country, but some unit we don't know. But we know that, oh, he does say dollars. Sorry, they did say dollars. That the profit in dollars. So he gets a profit of $0.85 or 85 cents for each bottle. How do I know it's profit? Because they say profit is represented by the formula. And they give it a convenient name, P. They could have called it F. The name they give the function is the choice of the mathematician. We give it the name P because we're thinking that means profit. Same thing with B. Didn't have to make that B, could have called it X. It's just representing the number of bottles, B, bottles of water. So this would be like a short answer. Interpret the slope. The interpretation would be the slope represents the cost or the payment he gets from the customer as he sells each bottle. And that's flexible how you state that. And Paul's profit is increasing at the rate of 85 cents per bottle. Even though Paul's profit is negative, he is still getting closer to break even and then makes profit. Once he sells about 500 bottles, then you'll have made up for the 322 he owed somebody. So this one they have select an answer. Let's see what they have for the selection. What are the units? His profit is increasing at the rate of, oh, I happened to pick the right one, per dollars per bottle. So bottle is the x-axis, dollars is the profit amount, or the y-axis, and it's increasing at the rate of 0.85 dollars per bottle. An attempt to give you a real-world connection to all these formulas. Is that making sense to you? I'm hoping it's easy. We don't want to leave you in the dust here. Little by little, we'll get harder. And those are the 10 questions of that first one. Oh, okay. Let's make up a few. We'll look at the problem here, and let's make up a few on the board here, and let you solve it. I'll give you a formula. Let's do 3x plus 5y equals 15. I'm giving you the general linear equation. What is the slope and y-intercept? So slope and the y-intercept. This would be like the exam next Tuesday. A problem like this. Showing your work. Give you a chance to work through that. And now in the exam, you won't be able to use a calculator or your phone. No, you will be able to use a calculator. You won't be able to use your phone. But to show your work, you can't show your work on a calculator. Oh, we've got 3 people online. Michelle, Carissa, and Janaea. If you want to chat me your answer, that'd be fine. And then I'll work through it on the board, and you can check to see whether I've got it. And the exam will be just the time in this class. I'll give you another minute, and then I'll go through the answer. All right, here I go. The whole idea is we want to get it in the y equals mx plus b format. All right, so we want to get the y by itself. Well, an easy way to do that, let's divide everything by 5, and then I'll have a single y there. So let's do that first. I get 3/5 x plus y equals 3. Well, now I got y here. If I just subtract 3/5 x from both sides, I get y by myself. So y itself. So y equals negative 3/5 x plus 3. I could have done 3 minus 3/5 x, but I want to put it in the mx plus b format. And now I know my slope is negative 3/5. And the y-intercept is 3. And depending on what the software test has been configured, they might want the point 0.03. So if it doesn't like 3, put the point 0.3. Now, put it in point slope format. What in the world? How would I get point slope format? I have to first find a point that it goes through. I know that it goes through the point when x is 5. It's at 0. I didn't tell you what point it had to go through. I just know the slope and the y-intercept. It's up to me to find a point that is on the line. If I choose 5, 0, it makes it a little easier. I could choose 10 and negative 3. If I gave you a particular point, my point slope format would be, if I said that's the point slope I want to have it from, with that point, I simply would say y minus 0 equals negative 3/5 x minus 5 plus 3. There is point slope format using that point. If I wanted to say point slope given that point, y plus 3 minus a negative 3 equals negative 3/5 x minus 10 plus 3.
How did you get like the x and y being 5 and 0, and then the 10 and negative 3? How did you choose those?
Because I was given the points. Give me the slope format, given that point. So when they give you a point, then you would just assume, yeah, they gave me a point that goes through the line. I made sure that I did give you a point that did go through the line. If they give you an invalid point, then they give you an impossible problem. So when they give you a point, you might have to actually check to see, does that point actually go through the line? Just in case they're doing a trick question. I don't plan on doing that to you on the exam. All right, let's do another couple practice here. Well, I guess we could go on to the next little practice here. The next section in our little practice on this concept has to do with different ways of finding the equation. So you got the point slope format. Actually, did I do that right? I think I didn't need to throw in this part. I just know I have the slope and the point that it went through. I made a mistake of adding the b back in there. Point slope, you don't have the b. It's just y minus y0 equals m x minus x0. There's no plus b. I messed up on that. Now, oh, this is something I was thinking of. As you were working on the problem, suppose I want to give the general form. And this is something that a lot of mathematicians like to do. Say, I'm given the problem in a general form, a times x plus b times y equals c. And I want the general form of that solution. I want the general slope y-intercept. Not knowing what a and b are, let's just leave them in there. Well, what would I do? I would subtract ax from b from both sides. I have by equals, and we'll put it in the x first plus the b part. So equals negative ax plus c. Well, now if I just divide both sides by b, I get the point slope form, or the slope y-intercept form. Y equals negative a over b times x plus c over b. So now I know any time that I'm given the formula in this form, I could just plug in whatever a, b, and c are, and right away jump to my slope y-intercept format. And this is something that mathematicians like to do, especially if all they need to know is just tell me what a, b, and c are in a formula. There's 3, 5, 15. I can just plug in my a, b, c here, and I'd get negative 3 over 5 for my slope. And c divided by b, 15 divided by 5, gives me 3. I can jump right to there just by plugging in what my a, b's, and c's are. Mathematicians love to do that all the time, especially as the problems get harder. Right now, there's just a few steps between getting from here to here. As these solutions get more complicated, these become a lot more steps. And I can skip all those steps if I have done the work with a general format A, B, and C from a formula like this. I can skip all the steps in between to something more complicated and just say, oh, doing all that work, I get to here in the end, knowing what A, B, and C are now, I can give you my answer. That's what algebra is all about as they get harder. This part here, doing linear equations, is the easier algebra, just to get you going on why we have these different forms, doing it on an easy problem that represents some real world problems, the easy problems. Once we have more exponents in there, it's the same approach. It just gets a little more complicated, but now we've had some practice with easy ones, going on to the harder ones. And I just love physics and stuff, so as I connect it to physics, then it's like, oh yeah, that's why we're doing all this crazy math. Here's a couple easier ones. Let's look at this one as we're looking through the content here, and I'll display this to our online friends. Some easy ones here. As it should jump out at you. What is the equation for the horizontal line going through this point? -3, 8. Should jump out you pretty quick after you've thought about what does the equation for a horizontal line look like?
Yeah.
It's just y equals some value forever, because a horizontal line goes through the x-axis at some value, and it's that value forever. So what's our y value? 8. So y equals 8 is the equation. Nothing more. X doesn't matter what x is. I always get 8 out. When they say horizontal line, that means it's always the same number no matter what x is. So when you see horizontal line or vertical line, although it does not have a valid slope and it's not a valid function, the formula for a vertical line is x equals something forever. No matter what y is, x is a certain value. So that's the formula, even though it's not a proper function, because y can, for a given x, y is anything. And it only has a domain of one value of x, which is a valid for a function. Okay, the equation of horizontal line going through this point. Same thing, horizontal line, doesn't matter what x is, full y equals 4. Now this is the one that is easy to graph, but given 2 points, we have to do a little more work. This is the one that takes up the most work. Given 2 points, let me fit that window to the screen here. Given 2 points, find the equation for the line. And this is where you ask, well, what format do you want the equation for the line? That's the hard part. I like the slope y-intercept because the slope is so easy to find. Given 2 points, I just do x1 or y1 minus y2 over x1 minus x2. So let's get do they say what form? Oh, they do ask it for slope intercept form. I love that format. So 3, -1, 2, -2. Those are the 2 points. Instead of a formula, instead of the general formula, we have gathered the data. And we're assuming we have a linear function, and we've gathered data, don't know what the units are, -3, -1, -2, -2, -2. -2. Right away, I know what my slope is. I take -2 minus -1 divided by 2 minus -3. Remember the order. I did this one minus this one divided by this one minus this one. Don't get your order mixed up. If you start with this one, make sure you start with that same x going that direction. So -2 minus -1 is a -1 over 1. -1. So slope is -1. How do I get the y-intercept? Got to plug that in. I know that y equals -x plus some value of b I haven't figured out yet. So I have to plug in at either point. So I know that when I plug in I know I get a -2 when I have a 2x. Or sorry. Yeah, when I have x of 2, -2 equals -2 or -1 times a -2 x. B, what is b? Looks like b is 0, right? Add 2 to both sides, 0 equals b. So that makes sense? When x is 0, let's do a check. So I think my formula is y equals -2x. Uh-oh, I know it's wrong because I don't get that. I did something wrong here. Check my slope. -2 minus -1, it's -1. 2 minus -3, 1. Slope is -1. Y equals -x plus b. -2 equals -2x plus b. I've got to have my slope wrong. -1. y equals negative x, negative 1x plus b. I have to figure out what b is now. Plugging in a number, negative 2 equals negative 2.
I don't think there's no.
So also negative 1.
2 minus negative 3, isn't that a 5? Negative 1 over 5.
Yeah.
Oh, I'm an idiot. Yep. I had to have something wrong with those. I was just had a little brain blurb there. So yeah, so negative 2 times negative 5. So negative 10x, negative 2 equals negative 1/5. So negative 2 over 5 plus b. Now I can figure out what b is. What is b? Add 2/5 to negative 10/5. I get negative 8/5 equals b. So now the solution is y equals negative 1/5 x minus 8/5. Get your subtracting negative 3 from 2 right. For some reason I have a negative 2 in my mind there. We'll finish up this section on Thursday and maybe give you some practice problems. That will be, I'm going to take a look at the exam and make sure I cover on practice what you will have on the exam. You have any questions about anything? Do lots of practice problems. There's YouTube videos about them that may show it in a different way. Yeah,
Was the exam Thursday, you said, or is it going to be?
next Tuesday.
Next Tuesday.
Yeah.
Okay.
And I'll take a look at it and make sure that you are practiced up for it. Have a great day. And I'm going to stop the recording in case you want to go back and look at my messing up on that.